Hi, welcome to JK Tech Solutions. In this video, we are going to discuss how to do the stress analysis on a L-shaped bracket whose one end is a fixed constraint. Another end, on the another end, the taper load is going to be applied. To do this analysis, first of all, we have to start the Ansys, open the Ansys APDL. In this, first of all, we have to go for preferences, structural, okay. Then come for preprocessor, add, edit or delete, add, and here we have to take in solid quad 8 node 183 nodal element we are going to be consider, okay. Then come to options. Here the element behavior we have to consider plane stress with thickness, that means plane stress condition, okay. Then it one should be closed. After that one, come to material properties. Here material models, come to structural, then linear, then elastic, then the material behavior is a isotropic behavior. So we can go and check it. So here the Young's modulus is 30 into 10 power 6. Poisson's ratio is 0.27. So that you can come here 30 into 10 power 6 e power 6 e6. Then here the Poisson's ratio is 0.27, okay. Then it is going to be closed. Then you can come to real constant, add, edit or delete, add, okay. Here the thickness we can assign as 0.5, that is 0.5 thickness, okay, close. Then we can come for modeling. In this modeling, create areas. In the area we can consider as a rectangle, and you can check this image. If you can create a rectangle, first one, here we can consider first rectangle as a coordinates, this particular point as x1 comma y1 0 comma 0, and this particular point x2 comma y2 as 6 comma 0. So we can rectangular by dimensions. X1 is 0, y1 is 0, and x2 is 6, then y2 is 2 inches. Apply. In the same manner, you can consider next rectangle which is having a dimensions of from this particular location. That means x1 comma y1 is 6 comma 4 comma 2. Then this one is 6 comma 4. So that we can apply this one by dimensions. First one is 4, 2, next one is 6 minus 2. Then you can click on OK. Then you can come to a circle. So here in this video we are having a circle, the circle which is having a radius of 1 inch, okay, and the dimension is we can take in the center point of the circle which is having a dimension of 0 comma 1. X is 0, y is 1, and radius is 1. So circle by dimensions, cancel. Solid circle, x is 0, y is 1, and radius is 1. Apply. Yes. In the same manner, here at the right corner, here the x is 5, y is minus 2, and radius is 1. So x is 5, y is minus 2, and radius is 1, okay. Then you can operate. Here we can come for booleans, then we can add. So areas you can pick all. So the complete areas are going to be added into a single one. In the same manner, then can come here and you can check here. Here there is two more small circles are there. Now we have to create these two more small circles into a L bracket. So that create area circle, solid circle, where the x is 0, y is 1, and the radius of the small circle is, you can check, 0.5. Apply. In the same manner, here one more small circle is there, so which is having the radius of 0.4. Or here also a 0.4 radius, so that we are going to delete this one. Let us see how can we delete. So first of all we have to come to delete, then areas only, then select this area, okay. So that here delete, we are deleted. In the delete portion we have to again create. So create area solid circle, then first of all x is 0, y is 1, which is a radius of 0.4, okay. In the same manner we have to create another solid circle where x is 5, y is -2, and the radius is 0.4, then we are click on OK. So now we can come for operate, booleans, subtract, areas. First pick larger area, okay, then smaller area, okay. In the same manner next pick larger area, okay, then pick here, there is another smaller circle, click on it, okay. Like this we can create. Then come to here meshing. Here we can use a mesh tool. Then first of all select on area, set, okay, okay. Then I am taken here the edge length as 0.05, okay. Then again by using of quadrilateral mesh I am going to start mesh here. Yes, by doing on quadrilateral mesh you can observe here in this particular location where here the meshing is not in a uniform manner. You can observe clearly here where here the meshing is not a uniform manner. That means there is a different types of meshings came. Here you can see there is one triangular mesh is also came. So that in order to do the uniform mesh, what we have to do means we have to go for a triangular mesh, then mesh, click on select the element, okay. It will ask do you want to remesh them, okay. So that here we can see there is a uniformity is there in the meshing. Wherever you can see there is a uniform mesh is possible. So this is the difference, uniform mesh is possible, yes. Then we can come here, then we can go for a loads, define loads, apply structural, okay. Then you can check here, here in this particular case here there is all degree of freedom is going to be constrained. So in the same manner we have to do displacement on lines, so that we have to select on lines, select only these lines, corner lines, okay, okay. So that okay, all degree of freedom is going to be arrested. In the same manner next we have to apply a load, but here there is a tapered load is there which is 50 to 500 lb. So that how we are going to apply it means we can come to here, we can come on structural, then pressure, then on lines. First of all select this line, okay. Then here we are going to apply it 50 to 500 because it is a tapered load, apply. So here the pressure is applied. In the same manner we are select this particular line, okay. Then here we are going to apply 500 to 50, okay. Like this we are going to apply the pressure on it. You can check, yes, already the loads and pressure are given, allotted, Next what we have to do means close all the preprocessor elements, then come to solution, then here solve, current ls. Okay, then it is going to solve. Yes, solution is done, so that it is going to be closed. Then come to general post processor to view the solution, then plot results, contour plot, nodal solution, and in this nodal solution first of all we are going to check the displacement vector sum, that is nothing but a displacements. We are going to click on OK. So see, this is a displacement where here this one is a simulation image where here the blue color represents the minimum displacement and the red color represents the maximum displacement. Here the minimum displacement is 0 because at the rate of fixed supports, so the displacement is 0, and the maximum displacement is at a load where we are applied. So here there is a tapered load we are applied. So in this particular location, this red color represents the maximum load. If we want to check how the loads are applied, how the structure is subjected to that particular load, we can run the animation. To run the animation, we can come for plot controls, animate, then we can click on a deformed results. So we can select the frame. So if I am 20 seconds and delay is 0.5 seconds, DOF solution, that is total vector sum. That is vector sum is summation of ux, uy and uz. Okay. So you can check this animation where here this one is a fixed support Mn and here this is a maximum displacement subject. So by applying a taper load, this rectangular bracket will bend to downwards, and here I am selecting forward and backward. If I am click on forward only, so that it will displace in only forward direction, then we know that so at particular nodes the displacements are going to be find out at nodes, so that the displacement can check at nodal solution. Yeah, like this displacement is happen, stop, close. And in order to check the stresses, we have to go for element solution because the stresses can find out in elements. So that element solution stress, here we have to check a 3D stress, that is nothing but a Vonmises stress. Okay. So with the help of elements we are going to check it. So in the same manner we can check stress to clear representation in the nodal solution also. Okay, yes, this one is the stress where here the stress minimum is 0.088253 lb and maximum lb per inch square. In the same manner maximum is 3106.36 lb per inch square. So we have to see the animation means plot control, go for animate, then deformed results you can set here. So stress, you can click on what type of stress we are going to be visualized. If I want to visualize Vonmises stress, okay. Yeah, like this. By application of a forces, here the stresses can generate at fixed support. So here there is a maximum stress is generated. Yeah, like this we can check. If we want to list out the results, so where the how many nodes are there, list results, then you can go for nodal solution, DOF displacement vector sum. Okay, like this you can check. We can got totally how many nodes are there at each node, what is the displacement in x direction, y direction and z direction. Actually it is a 2D element, so that there is no displacement came in z direction. So u sum is the summation of ux and then uy. So displacement in x direction and displacement in y direction. Like this you can check they are totally this much of nodes are generated. In the same manner, if you want to check the same thing for elemental solution, you can come, you can check the stress, then we can check the Vonmises stress. Okay, from this you can check, so totally how many elements are there by down scrolling this one. There are totally 16,262 elements are there. So like this we can check it. Then if you want to check the, so how many amount of nodes are there, we can go for plot controls, numbering, then switch on the numbering. Here node numbers, click on it, okay, on, so that here the nodes will generate. In order to check the nodes, you have to come for a zoom in. So see, so wherever the stresses are there, the all stresses is going to be visualized in this particular thing. Okay, like this it is going to be generated. Okay. Okay. So to save this image, we can come for file, then report generator, then append OK. So here we can click on photo, OK. So that like this the nodal solution is going to be clicked out. In the same manner we can do the Vonmises stress also. Close. Then you can come to particular location. For suppose my data is in stress analysis report, and here images, and you can check here the displacement is already saved in this particular format. Okay. If you like my video, please like, comment, share and subscribe.